Hello everyone, welcome back to lesson number 25 for BC Calculus, where we're talking about differential equations and how to solve for them. In this video, we're going to do 3 more differential equations where each of them have just a special little thing I want to talk about. And let's go ahead and get started. So example number 3 says solve the equation dy dx is equal to x minus 2 times y squared. And so the very first thing we're going to do here, just like in the previous video, is we're going to separate our variables. So we're going to get dy over y squared is equal to x minus 2 dx. All right, so separation of our variables is good. Again, all the x's on one side, all the y's on the other. We're going to now throw in our integrations. So we're going to integrate both sides separately from one another. So we'll do that. And, when we're integrating this right here, remember this is going to be y to the negative 2. Right, so we're going to integrate y to the negative 2. So y to the negative 2 is going to be y to the negative 1 all over negative 1. Again, just please make sure that you guys don't think that this is a natural log problem. Remember that it's only a natural log problem if the exponent is 1, right? If the exponent is 1. So we're integrating y to the negative 2. Again, it's going to be y to the negative 1 over negative 1, which is just negative 1 over y. We'll get that in a second. And then we're going to integrate the right side here, and we're going to get x squared over 2 minus 2x plus c. Now this question, there's no initial condition, so we're just going to leave c alone and just kind of play with it a little bit of time. So let's continue on with this problem and just simplify the left side. It's just being negative 1 over y. And then this side here, again, we'll just leave it alone and just do 1/2 x squared minus 2x plus c. Now, this is where I can say to you guys with confidence that you can leave your answer like this. All right, so, I said in the first video that most of the time you want to essentially solve for y. Well, you already have a simple function of y right here in your, in your equation. So we can say that the solution to this differential equation, because I can plug in any value for x and y, and I can get very easy numbers for this c. So this is totally fine. What I do want to say to you guys, though, and again, just making sure that we're cool about this, is that if you want to get it in terms of something else, you could multiply everything by negative y, and you could essentially, like I said, if you wanted to do it, you could do something like this. And again, we have a random plus c, right? A random plus c. So that will be it. So this is another solution to that problem. So this is a better solution to the problem, but you could go ahead and do that. And you could have also multiplied everything by positive y too. It really doesn't matter. But this is an example where you don't literally have to get y by itself. You just want a really simple expression of y on one side, and then everything else on the x on the other side. So now let's look at question number 4, where we have solving a differential equation, and we are giving an initial condition. All right, so I'm going to kind of take these two questions and put them together. I'm going to do the same thing for both. I'm going to work on them at the same time. Is what I'm trying to say. I'm working on both at the same time. Let's go ahead and cross multiply in this particular example to get our solution separation of variables occur. So we get 6x squared dx. So we have these right here, which is good. And just like in previous examples, we're going to go ahead and integrate both sides. And yes, you could put parentheses around that if you want to, but you don't really need to do that necessarily. And so we integrate 2y. Well, that just simply becomes y squared. We integrate cosine of y. We're going to make that positive sine of y. And then on the right side here, we're going to go ahead and make the integration of 6x squared as our 2x cubed. I'm trying to do all this stuff in my head, so 2x cubed. And then we're going to do a plus c. Now, ladies and gentlemen, this is where I want to tell you that this is where I incorporate this. I want to find the solution to this equation that satisfies the initial condition. Now, you can wait to the very end and do it, but this is where I'd like to find the c. So this is where I will want to do it. So when y equals pi, because again, I don't want to manipulate this. I want to just be able to figure out what's going on with it. So y squared, sine of y squared, pi squared, and then we get sine of pi is equal to 2 times 1 cubed plus c. Well, the sine of pi is just 0, right? So that's 0. So I'm going to get sine or pi squared, pardon me, and then this is going to be 2. So I'm going to get that c is going to be equal to pi squared minus 2. Okay, so again, why I like doing that is because now here I can just go ahead, and write that c is going to be pi squared minus 2. And this is our solution to our problem. There is no way we can get y by itself. And so this is the equation, this is the solution to our equation. And ladies and gentlemen, again, the purpose of solving a differential equation is really just to get rid of the dy dx. Give ourselves an equation in terms of y, x, and constants. And that's exactly what it is. So once you get to this part and you find what c is, you're pretty good. You're pretty good. The reason why we simplify usually to solve for y is because multiple choice questions will give you your answer in terms of y. But this is the best we can do. And that's exactly what we're going to do with this question, is leave it alone. All right, so let's look at example number 5. Now this one right here, it's actually given us a differential equation, and it's just telling us again the initial condition right here. So we're basically don't have an a and a b. We just have to solve everything like we've been doing before. So just like plenty of times for this, we're going to separate our variables. Now remember, the y prime is really the same thing, and you guys know this. Y prime is going to be equal to dy dx, so it is a derivative. So I'm going to go ahead and maybe write that as dy over dx, so it's easy for to see. So let's go ahead and move the y over. So we're going to move y over here, dy, and then I'm going to go 1 plus x over x dx as our example right here. Okay? And again, we have done our traditional separation of variables, which is great. We're going to go ahead and integrate both sides. You guys can see the pattern here of what's going on. And when we do that, we integrate our left side. Well, this again becomes y squared over 2. So this will be a very easy problem for us to get y by itself. And then this right here, some of you would be tempted to be like, maybe try some u sub, or it's something. What you have to do for this problem is you have to integrate by separating your numerator. Okay, so again, just a strategy, we haven't done it in such a long time, but you can separate your numerator and get 1 over x plus 1. And so when we integrate this, it's going to be the natural log of x, well, the absolute value of x, which is always the absolute value of x, plus x, plus c. Okay? So again, I chose this example because of that integration right there, because sometimes people forget the simple stuff. Right now, right then here, I'm going to go ahead and find out what my c is. So I'm going to go ahead and plug in -4 for y. -4 squared is 16. 16 over 2 is going to be 8. So I'm going to go ahead and say the 8 is this left side. Get the natural log of the absolute value of 1, which I hope you guys know what that is, plus 1 plus c. So the natural log of 1 is 0, right? So that just goes to 0. And so I'm going to get that c is going to be equal to 7. C is actually equal to 7. So now that I've done this problem, I can now say that 1/2 y squared is equal to the natural log of the absolute value of x plus 7. Plus 7. And this, again, is a legit answer to this problem. We could stop right here. This is totally fine. We have an equation that we've got rid of the dy dx in terms of y, x's, and constants. But the multiple choice question would actually have it simplified for y. Now, this is why I do want to do this problem, because just let me continue with it, and I'll show you guys why I really want to do it. So we're going to go ahead and multiply everything by 2. Okay, so we're going to go ahead and multiply everything by 2. So we're going to go ahead and do the natural log of the absolute value of x plus 2x plus 14. Plus 14. And then we're going to, and by the way, if you didn't find the c here, when you do it at the very end, it should still give you the same value. And then we're going to get y is equal to the square root plus or minus square root of 2 natural log of absolute value of x plus 2x plus 14. And maybe, and I think this would be very mean, but maybe on the exam, multiple choice A would be the positive square root of all of this, and multiple choice B would be the negative square root of this. And so you'd have to figure out which one of these we want to use. Well, again, what we want to do is we want to make sure that the initial condition is satisfied based on our final answer. So if I plug in 1 into my problem here, then I'm going to get 0 here. I'm going to get 2 here. I'm going to get 14 here. So this is going to be the square root of 16. So if I want the answer to be a -4, then the solution that I want, the y that I want, is going to be the negative value of this, because this is going to give me a positive square root of 16, right? So this is going to be the solution. And like I said, I don't think this would ever be something that they would test you on, but it's always nice to just, in the video, tell you guys just what I've seen in the past. So I want the negative one, because that's going to satisfy this equation, this initial equation right here. All right, so I've got one more thing I want to show you that's not in the notes, but I just think that this would be a really good example of something that students may see on the BC exam. So something like this. Something like this. Now, we are going to learn how to integrate exponentials in this lesson, so I haven't really got to it yet, but just, as a foreshadowing, what to do, set it up, and then eventually I will solve this question for you in another video. But if we want to be able to separate variables like this, it's not easy to, subtract y. You can't do that. So what you're going to do here is what I talked about in the very first video. We want to use power of exponents. Power of exponents, especially for exponentials, to be able to do it like this. To rewrite e to the x plus y as e to the x times e to the y. You want to be able to really separate your variables. And so then when we do this problem, when we actually do the rest of this, we're going to have, dy over e to the y is going to be e to the x dx. And then we're going to integrate them both this way. And so I'm going to come back to this question in another video, and then I will talk about how to integrate this stuff. But right now, I just want to say in the last couple minutes of this video that if you see something like this, you can use properties from algebra, properties of exponents, something that you have learned in the past that can split this up. Therefore, you guys can then do the separation of variables, because we're going to hit this hard when we do the applications of the applications of the differential equations that's still in this lesson. All right, so I've said enough for this one. Thank you guys, and I'll see you in the next video.